All right, we are now going to calculate a 2 by 2 systems of equations using determinants. Now, I'm going to teach you two different ways, and it's going to be up to you to decide which one you like better. And it's going to take a long time for me to do both of them. All right, so something I already started doing in our example, we're given these systems of 2 by 2s, and I created it into matrix form. So this first matrix is just the coefficients of the x and the y. And it's really being multiplied by this coefficient, or I'm sorry, by the x and the y. It's the column matrix. And it's set equal to the column matrix of the solutions. Okay, so the first way I'm going to do is use inverses. So just like in normal solving a system, you do the inverse operation. So to get rid of this coefficient matrix here, I'm going to multiply both sides by the inverse of that coefficient. So it's going to take me a little bit here just to write all that down, but this is why using your calculator to do matrices is actually probably a lot more effective. And there's a couple slides in our notes for you that actually showed you what buttons and where you could find them, but you can also Google. It's up to you. Alright, so I'd recommend looking into that. It goes a lot quicker. That is how Miss Rudolph actually did this one. Okay, so I kind of skipped ahead a little bit. But essentially, to get rid of this coefficient matrix, like I said, I'm going to take the inverse. So I really am raising it to the -1 power. Now, it's very important if you're going to type it into your calculator, if you're going to solve it this way, that when you do to one side, you do the other side, but you have to put it in front of the solutions. You have to put in the inverse matrix in front of it. Okay, and I'm not going to go through the whole process of calculating the inverse because even if you just type in this part into your calculator, the matrix raised to the -1st power being multiplied by our solutions, you're going to get the answer. When you type it into your calculator perfectly, you're going to find that x and y, they'll show you that it's equal to this column matrix, 8 and -3. So if you were to plug those back into your system of equations, you'd find that 8 and -3 are your solutions. So that is one way of doing this. But there's another way of doing this called Cramer's rule. And actually, I prefer Cramer's rule because we don't know how to calculate the inverses of 3 by 3 matrices. It's a very long process, and it's not something you'd actually really enjoy doing. When you get into college, if you ever decide to be a math major, like myself, you're actually going to be dealing with matrices that are 10 by 10s. And ironically, this was actually probably my favorite part of college. Alright, so once again, I'm taking my systems, and I'm going to do something called Cramer's rule. And Cramer's rule uses determinants. The first determinant, D, that I'm going to make is going to use the coefficients, just like that very first guy actually in our systems that we were just using. So the coefficients of the 4, the 2, and the -3. Where the first column are my coefficients for x, and my second column are my coefficients for y. Okay, so that is my first determinant that I'm doing. And if you were to calculate that, you'd find that your determinant is equal to -16. Okay, the next part you need to do is you need to find your determinant dx. Okay, this is going to actually help you solve for your variable x. And what you're going to do, because that first column were your x's coefficients, you are going to replace the x coefficients with your solutions. Okay, so once again, because I'm going to start solving for my x, I'm replacing the x column. The y column is actually going to be left alone, left the same. So you're going to calculate this determinant. We calculated him to being -128. You can check my math if you're really questioning me. Alright, and so before I do y, let me just show you why we're doing this. X, to solve for the variable x is really being equal to that determinant dx that we just did divided by a determinant d. So we're really taking the -128 and dividing it by -16. And if you divide -128 by -16, you find that x is equal to 8. So far, so good, because we just got that. Alright, the next determinant I need to do is my y determinant. Now, when we did the x determinant, we actually replaced the x column. Now, because we're doing the y determinant, we're going to replace the y column. So my original x column is going to stay the same, and I'm going to replace my y coefficients with the solutions. Okay. So if you were to calculate that determinant, you would find that that is equal to 48. And just like what we did with x, y, he's actually equal to the determinant dy divided by the determinant d. So 48 divided by negative 16, and you get that y is equal to negative 3. There are your solutions. All right, this is our last one. We are going to do a 3 by 3 system using Cramer's rule. All right, just like we just did, we are going to set up the determinant d using all the coefficients in our equations. The first column here is the x, the second one will be y, and the third one will be z. All right, so we're setting him up 2, negative 2, 2, 1, negative 1, 3, negative 1, 3, and negative 2. All right, so if you either type this in your calculator or if you do it by hand, which you will have to be able to do, you find that this determinant is actually negative 8. All right, the next process, we're going to set up 3 more determinants. The first one we're going to do is dx. Now, if you recall, when we're doing dx, we replaced the very first column, because those were all the x coefficients, with our solutions. So negative 7, 17, and negative 12. All right, so then the rest of the columns will stay the same because this is the dx determinant. And we're not touching the coefficients of the other variables. So if you calculate the determinant for dx, you find that that is equal to 8. All right, and if you recall, x is equal to dx divided by d. Therefore, x is equal to 8 divided by negative 8, so x is equal to negative 1. All right, so now we're going to do dy. I'm going to run out of room before we know it. When we're doing dy, the only column that'll change is the y column, so this time our middle column is going to change. So the first column is going to stay the same. The middle column, which is my y column, he gets the solutions as his new numbers. And my third column, which is my z column, that'll also stay the same because we're not dealing with z, we're dealing with y. All right, so if you calculate our y determinant, you find that that is 0. Uh-oh, do you recall what that means? If the dy is equal to 0, that tells me something about my determinant. I'll give you a thought as to what it means.